In this video, we're going to do 1b from the warm-up question. So in this case, we're looking at how many molecules of aluminum chloride can be produced from 60 grams of aluminum. And so the question starts off generally the same way. You start off by making a balanced equation, so we're not going to forget to balance that equation in this situation here. So let's go ahead and start that. So we have step 1 here. Let's get the ink working. Okay. All right, step 1, we have aluminum, solid aluminum reacting with hydrochloric acid, and that's aqueous, to produce aluminum chloride plus some hydrogen gas. We make sure it's balanced. That's the first most important thing to do, making sure that it's balanced. And so we put a 2 here, a 6 here, a 2 here, and a 3 here. And I believe 2, 6, 2, 3 was what we had in our previous example there. And we have a mass given to us over here of 60.0 grams, so 3 sig figs there. And what we want to find over here is the number of particles. And so remember, the number of particles is equal to the number of moles times the Avogadro's number. And so we know Avogadro's number already. Just a little reminder here. Avogadro's number is 6.02 times 10 to the power of 2023 AlCl3 per mole. And the AlCl3, the reason I put that there is because it's particles per mole, and in this case, the particles we're dealing with is the aluminum chloride particles. And so we want to know how many formula units there are for aluminum chloride if 60 grams of aluminum react. And so we can't go from mass to number of particles directly like that. So that's not a possible route. So what we need to do is go to convert this to moles first. And then once we're at moles, then we can use the mole ratio between aluminum and aluminum chloride to find the moles of aluminum chloride, and then use that in our equation to find number of particles. And so we had done this in the previous question, so it's going to be essentially the same thing. So the number of moles is going to be equal to the mass over the molar mass, which we found in the previous question to be 60 grams over 26.98. So 60.0 grams over 26.98 grams per mole. Cross that out, cross that out. I'm just going to do it in my calculator again here. So 60 divided by 26.98, and I get 2.223869533 moles of aluminum. And now I can write a mole ratio between the aluminum and the aluminum chloride. And just right off the bat, we know it's a 1 aluminum to 1 aluminum chloride ratio, or you can write it as a conversion factor as 1 aluminum for every 1 aluminum chloride. And so now we can use that conversion factor. And again, that's based on the balanced equation. It's a 2 to 2 ratio, which is really a 1 to 1 ratio. And now we can use our conversion factor to find the moles of aluminum chloride. So let's go ahead and do that. So we're going to do that the moles, oops, stylus is acting up a little bit. There you go. Moles of aluminum chloride are going to be equal to the moles of aluminum, so 2.223869533 moles of aluminum times, we want to get rid of the aluminum, so we have 1 mole aluminum on the bottom and 1 mole aluminum chloride at the top there on the numerator. So we can cross out moles of aluminum, and we're left with that the moles are 2.223869533 moles of aluminum chloride. And so now what we can do is we can convert that into particles. So we can convert that into particles by using our equation from up here that we had earlier. So our step 5 is going to take that number of moles and apply it to the equation that we have there. So step 5, the N is equal to the number of moles times the Avogadro's number, which is equal to, and I just want to make sure my number of moles are correct. Sometimes you punch in things incorrectly in a calculator. We have it right. Okay, we're great. So I'm not going to write all the digits down here, but I keep it all in my calculator. So 2.223869. And then you could keep them in your calculator. Moles times the 6.02 times 10 to the power of 23 aluminum chloride per mole. You cross out the moles, and we get, so times 6.02 times 10 to the power of 23, 1.33876945 times 10 to the power of 24 aluminum chloride particles. And don't forget, though, we need to have the proper number of significant figures, and that is 3 significant figures that we need to round to. So basically up to here, I look next door over here, and I'm rounding up. So that's going to be, let's do our step 6 here is therefore. There are approximately 1.34 times 10 to the power of 24 aluminum chloride formula units or particles. And so that there is the final answer, rounded to the correct number of significant figures. We use the mass of aluminum, found its moles, use the mole ratio between aluminum and aluminum chloride to find the moles of aluminum chloride. We then use the moles of aluminum chloride and plugged it into this formula over here to find the number of particles of aluminum chloride. So it was very similar to the previous question. It's just that our end result was that we used a different formula. Rather than find the mass, we found the number of particles. And this question could be extended. So if you want to find the number of chloride ions or chlorine atoms, however the question is worded, you would then multiply this by, well, 3, because there's 3 chlorines for every aluminum chloride. And if you want to find the number of aluminums, well, it's equal to that number there because there's only 1 aluminum for aluminum chloride.